Welcome back, everyone. So for now, I'd like to thank our bronze sponsor, UnoSecure. UnoSecure is a cloud identity security platform designed to address identity and access threats across multi-cloud environments. Founded by Santosh Jayaprakash, apologies for butchering the name probably, and headquartered in Berlin. The company focuses on eliminating cloud permissions gaps and enhancing continuous security for organizations of all sizes. And with that, we have the fantastic Nick Frichette here with us today to talk about hidden among the clouds, a look at undocumented AWS APIs. Take it away, Nick.
Thank you. Hey, everyone. Thank you so much for being here. I'm really excited to share this research with you today. Some of you may know that there is a long backstory behind this project. I had originally intended to release this last year at Black Hat USA. AWS very politely asked me not to, and thus began a long back and forth on what's a reasonable amount of time you can ask a researcher to delay. Can you even ask a researcher to delay if there is no specific vulnerability, just a platform leaking information about itself? But regardless, all of that has since been resolved, and I'm really excited to get to share this. Today, we're going to be looking at my methodology for finding undocumented AWS APIs, some of the challenges associated with this research, and a call to action for the research community to take advantage of some of these findings. Your first question might be, Nick, what is an undocumented AWS API? For our purposes today, I'll define this as any AWS API that does not appear in the public documentation. Your next question might be, well, Nick, cool. Why do I care about those APIs? Well, it's important to note that undocumented APIs have been associated with a number of vulnerabilities, including attacker techniques and tradecraft that could be very beneficial for an adversary. This takes a wide variety of forms, including cross-tenant access, being able to leak information cross-account in AWS, or in a worst-case scenario, just straight up accessing other customers' resources. Another category would be some big nerd figured out you could bypass CloudTrail using it. And this has been an ever-present, ongoing issue where you can avoid CloudTrail logging by taking advantage of undocumented APIs. And in another category, privilege escalation. As far as I could tell, the earliest publicly known example of someone using an undocumented API in a security context was Spencer Geetson in 2018 for a privilege escalation vulnerability in the CodeStar service. And of course, many more. So why do we care about undocumented APIs? Because it leads to security vulnerabilities and tradecraft that is beneficial for an adversary. Well, cool. Now that we've established why we care about them, how do we find undocumented APIs? Because they are undocumented, theoretically, there is no centralized location where we can find large numbers of them to try and test and look for issues in. Well, it's interesting to know all of these examples here have one thing in common, and that is, in literally every one of them, there's a line in there, something to the effect of, we found XYZ undocumented API by digging through the AWS console. This is anecdotal, but one thing we've seen is that when AWS service teams need to accomplish things in AWS, or the console specifically, but the standard APIs either can't do it or can't do it in an efficient way, service teams will create wholesale new APIs, new operations, and new parameters to try and achieve that. So my hypothesis going into this was that we could use the console to find more undocumented APIs. For how we would do this specifically, we need to learn a little bit about AWS API models. AWS is very big on what they refer to as model-first design, where when they create a service, they first create a model that describes everything about that service. Now, these models are exposed as a part of the SDK. What you see here on the slide is pulled directly from the Bodacore library and is the model for the guard duty service. These models are incredibly important because they contain all of the information that you need, or at least almost all the information you need, to interact with that API. What API operations are there? What is the protocol used? What parameters does it support? And so on. Now, the reason we care about this in this context is because these models have a very standardized format. We always know there'll be a metadata section, an operations section, shapes, and so on. We know it'll be JSON, and they're typically held in a very particular order. And so this is useful because in the AWS console, the way these models are consumed or used is they just take this model, stringify it, chuck it in the front-end JavaScript. It's literally just a string. And so theoretically, what we could do is write a regular expression that matches this format. And we could look through the front-end JavaScript, finding these models and looking for operations, parameters, and services that are undocumented. This is a funny side note. When I went to get this screenshot, I just Control-F for the first JSON.parse, and it just so happened that the very first example I found included two services that are completely undocumented. For those in the back, the top one is for a service allegedly called Blitzen Service Lambda, and the one on the bottom is ESOP Console Service Lambda. So a little bit of foreshadowing for later. So far, we have established that undocumented APIs have a lot of security interest. And we developed a hypothesis of using the console, extracting out these models using regular expressions, and crawling the console. But that sounds like a lot of work. In order to crawl the entirety of the console, deduplicate findings, merge results together, grabbing each and every one of these models, that would take a long time and be sort of a pain. The good news is I took care of that for us. I built a tool called the Undocumented AWS API Hunter. And what this tool does is it uses Selenium to create a headless Chrome browser. It then logs into the console using an IEM user. And once it's done that, in the upper left-hand corner, there's a search bar. That search bar is powered by a bunch of JSON. Essentially what happens is client-side, whenever you type in a service name or something like it, it matches whatever you're trying to find with a service, and the way it knows what page to link you to is because that URL is just in the JSON. And so what this tool does is it grabs that JSON, rips out all the URLs that you need, and then programmatically navigates to each one, along the way grabbing all the JavaScript that gets loaded, running a regular expression against it to pull out those models, and then deduplicating them, merging them together, and so on. And once you have all those models, you then compare them to the Bodacore library, and if you find a service, an operation, or a parameter that doesn't appear in Bodacore, you've theoretically found an undocumented API. Now, like I said before, I've been doing this for a very long time. I started gathering this data on June 15th, 2023, and I have since run this automation twice daily every single day since. In that time, I have gathered 669 models. By comparison, Bodacore has 419, so we're already off to a great start. Throughout the remainder of this talk, I'm going to be referencing a number of stats and data that I've gathered. Know that all of this was current and finalized as of September 9th. That is a date that was very specifically chosen in honor of ForCloudSec's first European conference, because the day and the month are the same and can't get mixed up. So, before we get into the data, I have to stress, this is just the comparison between our extracted models and the Bodacore library. These are not the counts of working, functional APIs that we can use or take advantage of. Getting that count is much more difficult, and we'll talk about some of those challenges in just a little bit. To get us started comparing our extracted models to Bodacore, our first category, or our first type of undocumented API, is going to be undocumented parameters for documented actions. This is where a known documented API call has parameters that don't appear in the documentation, and we may potentially be able to take advantage of. As a completely random example, just to demonstrate this, here we have AWS Connect start chat contact, which according to the documentation has 11 parameters. But by extracting these models, we actually found 13, two additional ones, one for system endpoint and one for customer endpoint. Now, how many undocumented parameters did we find for documented actions? Not too many, just a few. We found 3,295. And you might notice there's an asterisk there. That's because we only compared top-level parameters. We did not recursively go down into the sort of sub-parameters and compare those. What that means, why we didn't do that, some of the challenges associated with it, you can find at the blog that is linked to that QR code, full write-up with an example. For the sake of keeping this at 20 minutes, chose to sort of add that elsewhere. For the purposes of this talk, just know that we have likely undercounted the number of undocumented parameters that exist. Our next category is going to be undocumented actions for documented services. This is where a known service has an API call that doesn't appear in the public documentation. As an example of this, we recently crawled STS assume root, which that sounds like an interesting API call. I want to assume root. Worth knowing, the standard STS endpoint doesn't work with it. You have to find the one that does, and it turns out it's prod_preview.sts. If you run it against that endpoint, it works. It doesn't succeed. You get back an error telling you that you're not allow listed to perform that call. So on a account by account basis, they're either permitting or denying it. One common question I get is, with all this undocumented API research, folks ask, are you able to see stuff before it's officially released? And yeah, absolutely, you totally can. And I'm fairly confident that STS assume root is something that's going to be publicly available based on the fact that the endpoint associated with it is prod preview and that they are allow listing by AWS account ID. So if and when that becomes publicly available, know that you found it here first. And also, really want to stress, all of this information is completely publicly available. There is no specific access required and is discoverable by anyone. As it turns out, the models themselves require actually no authentication at all to access, so you could pull them all completely unauthenticated. So how many undocumented actions for documented services did we find? A couple, 2,957. And that takes us to our final category, undocumented actions for undocumented services. This is by far the simplest. If the service is undocumented, all of its operations will be. And we're actually going to cover an example of this in just a little bit. And this time, no sarcasm, we found 8,442. So this is ultimately the challenge with undocumented API research. Because with 14,694 things that we need to test, there is too many for any one person to realistically assess this. If we were to say, hypothetically be so efficient that we could tackle each and every one of these in 10 minutes, which to be clear is a really optimistic goal, but let's say we could. It would take us 102 days of nonstop continuous testing to try and evaluate these. And of course, in that time, AWS will add new services, new operations, new parameters, which will make this a never-ending affair. When I started this project, I was afraid that I wouldn't find any undocumented APIs. I never imagined that I would find too many and be unable to assess them. Now, you're probably thinking, well, Nick, what are you talking about? Just automate it. You can't, for actually a variety of reasons. For the sake of brevity, I'll cover the top one, but know that even if you solve this next challenge, there's a whole lot that's standing in your way. It's important to note that just because you found a model doesn't mean you have the endpoint that you can use to actually invoke it. Some of them do use the standard, normal production endpoint, but the vast majority do not. And finding those endpoints is a significant challenge. Now, some of you might be saying, Nick, the endpoint is in the model. You can just use that. And I hear you. That doesn't work with undocumented APIs. As an example of this, here is the metadata section of a service called Amazon SES Internal. That sounds interesting. I want to invoke internal SES APIs. As a part of this model, and really any AWS model you'll find, there is an endpoint prefix section, which includes the endpoint prefix. In this case, email-internal. Normally, the way this is used is sort of plugged into a formula that's typically, although not always, endpoint prefix.region.amazonaws.com. It's not always the case, but in general, 90% of the time, these are the API endpoints that AWS uses. So, okay, well, let's take email-internal. Let's plug it into that formula, and it doesn't work. That domain does not resolve to an IP address. And so you might say, well, Nick, maybe it's a different region. Great idea, tried them all, doesn't work. You might say, Nick, maybe it's actually internal only. Well, in my experience, APIs marked as internal only are rarely actually internal only. And spoiler alert, we can invoke this service external to AWS. You might say, well, Nick, maybe you need to use the regular SES endpoint. That's a good idea. That has worked in the past. Here we're performing list cross-account identity notification attributes, which is a undocumented operation in that service. We're going to send it to the standard SES endpoint, and that doesn't work either. we get an error, could not find operation, which is a fairly standard error message. Anytime you pass an API call to an endpoint that can't deserialize it or doesn't understand what you're trying to invoke, you'll typically get an error like this one. So, all right, does this mean we can't actually invoke this API externally? Did Amazon win? Well, no. We just had to find the right endpoint. And after a lot of trial and error, we found it. Turns out it's frontend -internal .public .prod .usc1.ses.aws.a2z.com. If you use that endpoint, it works. What you see here on the left is a role that has 0 permissions at all. And the reason you do that is so that in the resulting error message, you can see what API operation is being called on the back end. In this situation, we can see that that is a standard, normal, documented API call. This is a situation that we've seen in the past where an undocumented API is, in a sense, proxying a normal, standard one. On the right, we have a screenshot with a user who has administrator access and the ability and successfully performs that API call and succeeds. The crucial thing to note is regardless of your level of privilege, none of this gets logged to CloudTrail. So you can use that endpoint and that model to determine what level of privilege you have with SES without getting caught. So this is one of the most significant challenges with undocumented APIs is just because you have the model, you don't necessarily know what endpoint is associated with it. Now you might say, Nick, I can see in that endpoint it says SES, and I can use that to try and cut down on the number of endpoints that I'm going to test. That's a great idea. I don't want to completely discourage it. That might work. You might be able to sort of reduce the amount of time spent. Maybe that's something you should pursue. I personally haven't because I know there's a ton of API endpoints for AWS that look like that. What is that? That is a real, valid SES v2 endpoint that you can use. And so there's no real way of knowing, unless you actually try the operation against it, if it's associated with that service. In case you're wondering, how did I find that, or the front-end internal one, there's a couple ways to enumerate AWS API endpoints. By far, the most effective is one that we've covered in the past by using certificate transparency logging to find the endpoints and then interacting with them to see their response. We can make a determination on if something belongs to an AWS API or not. If you're interested in that topic, you can find more information through that QR code link there. And that's how we find endpoints like these that realistically could not be brute forced. So you might say, all right, I hear you, Nick. Listen, I'm going to galaxy brain this. I'm going to try every single AWS API endpoint, and if one of them succeeds, I know that's the right endpoint. Okay. So here's the thing, though. With the automation we made, as of September 9th, there were at least 49,791 of those. So realistically, taking thousands of documented APIs against tens of thousands of endpoints is not going to scale in any meaningful way. So what now? We found thousands of undocumented APIs. And realistically, the majority of them are completely benign and uninteresting. They may not work. They may not provide any features or functionality that's new. They may not have any security benefit or any security impacts. But undoubtedly, some percent of them did have security impacts and are dangerous. In fact, 2 of the examples on this slide actually spawned out of this research project itself. So do we give up? No. Instead, this is my call to action for the security research community to try and help out. I've already open sourced the models that I've been gathering since 2023. You're welcome to look through them and find vulnerabilities or other services or techniques that would be useful. But there's a really old saying that if you give someone an undocumented API, they might exploit it for a day. But if you give them the means to find more undocumented APIs, then they can keep hacking AWS well into the future. And so for that reason, I'm also open sourcing the Undocumented AWS API Hunter. If you think there are ways it can be improved, maybe new regular expressions to match on different models, because there is actually more than one, or some other ways to crawl the console, you're more than welcome to submit a pull request. I'd be happy to take a look at it and merge it in. And with that, And one last thing, my personal recommendation for security researchers is to use this data as a part of your ongoing projects. If you're taking a look at a particular AWS service or technology, check and see what undocumented parameters, operations, or similar services there are, and maybe see if you can find something you can use in a security context. And with that, if you enjoyed this talk, you can find more of our research at securitylabs@datadoghq.com. Feel free to follow me on social media or reach out with questions. Thank you all so much.
Fantastic. Thanks for that, Nick.
Thank you.
So we have a few questions on Slack. The first one's a troll question from Ben, which is how many service teams have so far put "Hi, Nick" in their data models?
No, I'm actually really disappointed. Nobody has.
Oh, man.
Somebody did reach out on Twitter, and thank you to that person. Probably not watching, but in case you are, hi. But no, I've been waiting for somebody to put a model in, and I think that would be pretty funny.
So, but extending that, have any of the service teams reached out to you about any of this when you've reported some of this stuff through the outreach team or what have you?
No, so there was the one guy who reached out and sort of thanking me because he didn't realize that he was what's the right way to phrase this? Before the launch date, letting everyone know about a particular feature. So he was thanking me for that. But other than that, I haven't seen any other service team reach out.
That makes sense. And then, so we got one here saying, I'm guessing AWS doesn't consider unpublished APIs as a significant risk, depending on the situation. But what if the endpoints are enumerated successfully for a large number of these? Do you think AWS will continue or consider changing their stance?
Well, that's an interesting question. AWS does care in the sense that they asked for delays. So somebody cared. What they did specifically is not typically shared with us, whether that be undocumented APIs or like non-production endpoints. So I know something has happened, and anecdotally, in doing testing back before I disclosed, a lot more of these APIs worked and were functional. It's very clear that they've been tightening down and restricting that, but it's not really clear publicly, at least, what they've been working on.
That makes sense. And at this point, I think we'll open the floor for questions. What have we got in the room? Ah, there we go. Joel over there.
Sorry. Cool.
Two quick questions, sort of both concerning the list of undocumented shrinking. Like, how much of it do you see shrinking because these are merely, we'll call it pre-documented APIs that there's a launch coming up, and how many of them, like how much have you seen this shrink as things have stopped working as Amazon has disabled public access to them?
Good question. So the counts that I gave used like my full data set. If you were to run the Undocumented API Hunter today, get all those model, and then compare the two sets, you'll see approximately a 20 to 30% drop. Whether that's because they're worried about security impact or some sort of risk, not really sure. It's totally possible they may have just decided they no longer want to expose that, or it's not useful to them in some way.
So we got another one here from the Slack. Is there anything you'd recommend AWS do to do a better job of hiding these so that we don't find them?
Well, actually, honestly, do the opposite. I would appreciate being a little more transparent, because if it's possible for us to invoke them externally, why not provide more information than trying to hide it? I think I've sort of built a career on, no guys, I'm gonna find it one way or another, whether that be undocumented APIs or the endpoints themselves. So people are gonna do it. It would be much better if we made it more publicly available and known, so that we could find those vulnerabilities proactively.
Makes sense. Have we got any more from the room then? Yeah, one here.
Oh.
Thank you for the talk. Question about your research process specifically. So when you showed us all the undocumented APIs, but when you have already gone through specifically, for example, the ones that weird-looking random endpoints that you got, do you publish that specific research? For example, hey, we have gone through this. We know the use case about this. And yeah, no fun poking around on this one. Move on to the next target.
Yes. So unfortunately, for the endpoints themselves, we can't publish that data set. Those endpoints include, unfortunately, AWS employee names and aliases, and we were very politely asked not to disclose that. We tried for a bit, like, can we identify them and then exclude them. But honestly, when names are mashed up, it's really no different than what looks like a hash or gibberish. So at this point, the thing I tell researchers is we have a full methodology laid out on how you can find these endpoints. If you took the time to automate yourself, then you could get that data set and work with it.
I think we've got time for one more.
Yes.
Thank you very much for the talk. Just a quick one, follow up from Joel's question, actually. When you're finding that the models are being removed from the console, you find that those APIs are actually being disabled, or you can still call them, they're just not, like the models aren't accessible from the portal anymore?
From some nominal testing, it appears that some of the ones I've tried are still functional, like you can still reach them and call them. That being said, I haven't gone through all of them, so it's certainly possible that some have been disabled or you can't reach the endpoint anymore, something like that.
Fantastic. And with that, I think we're out of time. It's time for another break. Thank you very much.